Hello, everyone, and welcome to our final speaker of World Usability Day 2021. We are very excited to be having Henry Dobson joining us this afternoon to discuss how the introduction of artificial intelligence technology is changing the doctor-patient relationship and what medical practitioners can do to navigate complexities involved. Henry is joining us today from Australia, where he is the founding director of the Institute of Technological Ethics, which focuses on the social impacts of modern technology and how it's changing our personal life. He's also a PhD candidate at the University of Melbourne, where his research focuses on the application of AI ethics principles and the moral theory required for justifying them. During his presentation today, if you have any questions, feel free to post those on the Yammer page for the Q&A session that'll follow the presentation.
Jacob, thank you very much for the introduction, and thanking you all for having me join you today and for allowing me to give this talk, which is introducing Dr. AI. So as Jacob mentioned, I'll be talking about how the introduction of artificial intelligence technology is changing the doctor-patient relationship and what medical practitioners can do to navigate the ethical complexities involved. Okay, so I'd just like to preface this talk by just pointing to something which the new CEO of Cerner, David Feinberg, said during a keynote talk recently, which is that we must eliminate the noise. He said, usability of technology is just the beginning and not the true promise of the digital age. Fixing the EHR, which stands for electronic health records, is our first job. Pipes are laid through 40 years of digitization, which is wonderful. But now we have to make it easier to get the right information to the right people at the right time. Yeah, I thought this quote was just particularly pertinent to the talk today because, of course, technology is changing the way that information is being delivered and obtained, and of course the communication between doctors and patients. But of course now this includes the interaction with technology. So I just found that to be a particularly interesting talk, which was given by David Feinberg recently. So the outline of the talk is as follows. I'll give a brief definition of artificial intelligence, as this will be important in thinking about some of the complexities involved with using AI in the medical field. I'll point to one example, which is the deep algorithm as used in the Mount Sinai Hospital in New York. I'll then outline 3 modes of the doctor-patient relationship using artificial intelligence, and then move on to the 4 AI ethics principles that consider how this doctor-patient relationship and the dynamic of using AI within that relationship can be managed and addressed ethically. I'll then look at the complexities involved here, and I'll talk specifically about the notion of meaningful human control as a way of thinking about how doctors and clinicians can manage these complexities. So what is artificial intelligence? There is no single one definition of AI, but one way to think about it is that AI is a banner term that captures a number of computing capabilities. These capabilities basically imitate or replicate human cognition. Now, we can see AI working at different levels. One of the first areas is in object recognition, digital imaging, and natural language processing, among other capabilities. But we see this being applied to facial recognition systems, image analysis, among other areas. Another field is artificial neural networks. So these networks process enormous quantities of data, also known as big data, and performs statistical analysis to identify patterns, anomalies, outliers, and other predefined objectives. The AI neural networks are used for diagnosing illnesses in radiographs, PET scans, ECGs, and EEGs, among other fields as well. Machine learning is also a growing capability whereby computers learn from a process of repetitive data examination using predetermined processes to answer a particular question. It is an iterative process that is critically dependent on the integrity of a training data set if it is to generate reliable results or predictions relevant to diagnosis and treatment. This is made further complex by deep learning, whereby machines learn or are learning contemporaneously. Whereby machines learning contemporaneously merges multiple data sets which are iteratively evaluated in sequential convolutional neural networks. These operational steps may be invisible to both developers and users, and this leads to the notion of a black box algorithm. The difficulty of understanding the operations of the algorithm make the visibility of it difficult, and hence the notion a black box algorithm. So they're just four of the, I guess you could say, the major areas of artificial intelligence technology. And they're all becoming a part of modern medicine. So one example is the deep patient algorithm used in the Mount Sinai Hospital in New York. This algorithm is used to predict diseases based on patient records, but it can also predict schizophrenia and other psychiatric disorders well ahead of time. That is, to sort of understand what the likelihood of the disease might be at some point in the future. It is, of course, a fascinating algorithm to look at in more detail, and you can find more details at the Mount Sinai website there on the page. So this then sort of raises the question, well, where is or how is AI being used in medicine? Well, there are four distinct ways where it can be used. The first is for assessing the risk of disease onset and in estimating treatment success prior to the initiation of that treatment. Secondly, attempts to manage or alleviate complications. And thirdly, it can be used to assist with patient care during the active treatment or procedure phase. And fourth, it can be used for understanding the pathology or mechanisms of disease and what the ideal treatments might be for dealing with them. So deep patient's a particularly interesting algorithm because it is considered one of the most sophisticated algorithms in use today, and it uses a huge quantity of patient records for being able to give the assessments and the assistance as described there on the screen. Okay, so this brings me to the three different modes of interaction. On the screen here, there are actually three different diagrams, and they're each defined on the side by the title: conventional mode, integrated mode, and fully automated mode. And I'd like you to read them from left to right. Please don't read them vertically. They are three independent diagrams just there. And I should also mention that I've simplified the diagrams as found in the reference below, and I'll give the reference list at the end of this talk should you want to look more closely into the details of this. But for the sake of simplicity and for the talk, I've just simplified these interactions accordingly. So you can see at the top with the conventional mode that the electronic health records are fed into the AI algorithm, which then goes on to make recommendations to the clinician, and the clinician then makes a decision which is then communicated to the patient. At the decision-making stage, whatever the decision is can then be fed back into the AI algorithm, and of course that will feed into its development and sort of evolution as an algorithm. The second mode is the integrated mode in the middle there. Again, the electronic health records are fed into the algorithm, which then makes recommendations to the clinician. But then at the decision-making stage, the AI is still involved in that decision-making process. And it might be involved because there is real-time data coming into it, and that the process is a sort of a contemporaneous one, whereby the clinician is working together with the AI for determining what the best decision or medical advice might be for the patient. But the key point there is that the AI is involved at the decision-making stage. The third mode is the fully automated mode, and of course that again begins with the electronic health records being fed into the algorithm. But the algorithm then sort of leaps the clinician and makes decisions which are then passed straight to the patient. The key sort of stage here is the middle part, whereby there is no clinician involved. This is a fully automated system whereby the algorithm is advising what the patient should be receiving. So these are the three sort of basic and different modes of interaction that are currently happening within the medical space, and it's changing the doctor-patient relationship in very profound ways. And I'll look at these complexities going forwards. So this leads to the four AI ethics principles, which are each relevant to the modes I just mentioned. The first, second, and fourth of these principles are what are called AI ethics principles, whereas the third principle, autonomy and agency, is traditionally considered to be a biomedical principle. And this is where we're seeing biomedical ethics overlapping with what is now sort of the emerging field of AI ethics. And of course, the technology is generating novel ethical situations and complexities which need to be addressed by a larger suite of ethical principles, and hence why there's now a mixture of AI and bioethical principles for thinking through these complexities. So I'll talk about each of these four principles in more detail. With trustworthiness, in relation to the conventional mode, questions are arising around, well, how can doctors trust AI-generated medical advice? The key concern here is that the AI advice and the information given to the doctor needs to be user-friendly, and the process needs to be based on adequate risk-benefit analysis. Because the conventional mode sees the doctor making the decision on their own, it's important, therefore, that the advice given by the AI is user-friendly, such that the doctor is confident that they can understand what the advice means and how it's given in terms of what the AI was using to determine its own recommendations. So the doctor needs to be confident that the AI is providing the right information, basically. Regarding the integrated mode, the concern here is, well, what happens when there is a misunderstanding or conflict in the decision-making process between the clinician and the AI's involvement? At this point, this is where sort of legal boundaries and regulations become especially important, because they're required to protect both the clinician and the patient from any mistakes made by AI involvement. There's a much sharper sort of demarcation with the integrated mode because of the additional agency that comes into play, and the agency is the AI itself. So the traditional doctor-patient relationship is, of course, just between the doctor and the patient, but now that relationship is being made more complex, and it's also being made more dynamic by virtue of the AI involvement. So the law is particularly important here, but I won't go into any further detail, because it's of course a rabbit hole of sorts around how to regulate and apply laws that can deal with AI agency. Regarding the fully autonomous mode, can patients trust AI medical advice without a human in the loop? And this also raises concern as to whether or not this mode undermines the medical expertise of doctors. Without a doctor in the loop, of course, it's removing all of that medical expertise from that traditional process. And of course, you know, the patient traditionally depends on the doctor as the expert for dealing with the conditions at hand. But of course, in the fully autonomous mode, without a doctor present and without a human in the loop, that whole relationship changes in its nature. So that's a particularly concerning interaction, but it's also one that's not widely used much at all. And I wouldn't say that the fully autonomous mode is all that prevalent, but it's certainly moving towards this kind of mode in the future. I mean, if you sort of talk more speculatively, you know, lots of authors are talking about the future possibility of having AI programs that can substitute the doctor. So it does raise concern around how doctors are to be positioned in such an instance. Concerns around transparency, and of course this points back to the notion of a black box algorithm. So neural networks, and in particular deep learning networks, are incredibly complex, and so much so that the decision-making process as well as the outputs are opaque and even incomprehensible to the designers and programmers who developed the algorithms. So two questions arise here. The first is, how did the algorithm arrive at a particular output so as to give the medical recommendations? This question is really pointing to questions around, well, what were the statistical calculations, what rules and parameters were applied in the decision-making process? The second question is, well, why was a particular output given? And again, this points to the causal relations between the input and the output of the algorithm itself. Now, one concerning implication here is in relation to informed consent. The opaque nature of black box algorithms makes communicating the AI-generated medical advice extremely difficult. And it might just be that doctors have to admit that they don't know why or how a particular recommendation was made. Now, if a doctor can't explain sort of the why or the howness around a particular recommendation, that of course makes informed consent all the more challenging. And the entire relationship of, or the entire doctor-patient relationship really does hinge on the notion of informed consent and the ability for decisions to be made in a bilateral manner, particularly between the doctor and the patient together. So the complexity of black box algorithms and the issues of transparency yield this certain sort of complexity around informed consent. In relation to autonomy and agency, by introducing AI into the process, there is conflicting medical advice. So AI medical advice can stand in tension with a clinician's medical expertise and judgment. The three different modes involve three different kinds of conflict. The conventional mode sees the doctor's knowledge and expertise as being augmented by the AI. So in this case, the doctor's agency and autonomy isn't all that or is unaffected by the AI. All that's really happening in this mode is that the doctor is receiving additional medical recommendations as being given by the AI, but the doctor is still the one in charge. The AI is not involved in the decision-making process. It is involved in the integrated mode, however. So the AI is involved in the decision-making process, meaning that medical recommendations can be made without the doctor understanding why. When this happens, the agency of the doctor is diminished because if the doctor cannot understand the why or the howness of the recommendations being made, it gives rise to uncertainty and other concerns around the quality and the reliability of the recommendations given by the AI. So the doctor in this case might begin to either doubt themselves, or it might put them into a more challenging situation of trying to determine or even possibly decipher, you might say, what the best course of action might be. So yes, this reduces the doctor's agency and autonomy. Now, in relation to the autonomous mode, there's no doctor present in the decision-making process. So this calls into question whether or not the doctor is made redundant. Now, if the doctor is made redundant, then of course this removes the agency that is ascribed to being a doctor. And it also entails issues around just the autonomy of a doctor. Is the doctor subservient to the AI algorithm, or is in what way does a doctor stand in relation to an algorithm that is fully autonomous and what you might consider to be supreme in respect to offering medical advice and recommendations. But again, this is a speculative sort of conceptualization of AI, but it's certainly one in which the trajectory of algorithms is going. So it does need to be considered today, but more so in the future. In relation to responsibility, the question really is, who is morally and legally responsible when incorrect medical advice is given? With the conventional mode, the doctor is the one making the decision and is therefore morally and legally responsible for the advice given. Now, this basically stands upon just the traditional responsibilities that doctors have always had when they are the ones that are making the decision. But with the integrated mode, the AI is also involved in the decision-making process, which calls into question, well, who made the decision? Now, there is some sharing that goes on in this case as to what recommendations or decisions are being given to the patient. And because of that shared decision-making, It could be that in cases of conflict, a doctor might believe that a decision was made by the AI rather than themselves. And if that decision turns out to be incorrect or in some way harmful, then the question arises: well, is the doctor sort of immune from whatever consequences occurred as a result of the AI's involvement? And with respect to the fully autonomous mode, presumably this mode holds that the AI program is morally and legally responsible, given that there's no clinician involved. Of course, again, this raises the question: well, how do we draw sort of legal lines and demarcate the dynamic sufficiently enough that we can understand, which part of that decision-making process falls very clearly to the doctor and otherwise very clearly to the AI. But it also raises additional questions around who is exactly responsible for the AI program when it's fully autonomous. Is it the designers and the developers? Is it the hospitals? Or is it the technology companies themselves? Again, these are still very philosophical questions that are being debated today, but they do have immediate concern for additional stakeholders, be it the hospitals and the technology companies. Okay, so where do doctors and clinicians sit in amongst all of this complexity? Well, it might be unsurprising, and fortunately, they still sit front and center. And the general view is that doctors must be empowered with the notion of meaningful human control. So what is meaningful human control? Meaningful human control holds that the AI should be and can be controlled by humans, and that humans, not AI, retain decision-making control. So what does this mean? Well, it can mean a whole range of things, but I'll point to a couple of areas and ideas as to what means for doctors and clinicians. One thing is that it means that as things currently stand, and irrespective of the growing power and sophistication of AI-powered tools, doctors and clinicians must retain their moral and bioethical responsibilities as they always have. In other words, doctors should still feel confident in upholding their own morality as they do in normal settings, without artificial intelligence involved. So really nothing changes for doctors and clinicians in this sense. They are still sort of in the driving seat, so to speak. But it also means that doctors and clinicians must trust themselves first. It also means that they should seek ethical assistance from others if they feel that there is a conflict that requires additional oversight or deeper consideration. And it also means that they must make decisions according to the expert judgment. So just because an artificial intelligent algorithm offers recommendations which could well indeed be very helpful for making a decision, expert judgment still needs to be applied regardless to all of the available knowledge and information at the doctor's disposal. And finally, it's important to remember that unlike human beings who are moral agents, AI-powered tools and algorithms are non-moral agents. And what this means is that, well, humans, not machines, hold ultimate moral responsibility. And it's not simply because we want humans to hold moral responsibility. It's because of the fact that AI algorithms are not moral beings in and of themselves. And this is one of the most important distinctions to understand in relation to the nature of human beings and the nature of machines. One of our most defining features as human beings is our morality, our ability and capability of being moral agents. Algorithms and machines, on the other hand, are non-moral agents. They do not possess the moral psychology or any other moral capability that we do. And in that regard, AI tools and algorithms cannot make the same moral assessments, which is to say they don't have the same moral intuitions and the same moral sensitivities as we do as human beings. So that distinction's, I think, philosophically very important to see, because this is what separates man from machine, if you will. And when it comes to applying artificial intelligence in a medical setting, it's important to understand that, well, we as human beings are the ones that are the moral agent, not the machines themselves. And this is why it's important that we maintain, meaningful human control right across the board, no matter how much AI is involved in a particular setting. We need to be, or doctors and clinicians, that is, need to be the ones in charge, despite the sophistication of the technology available. So this just should help doctors and clinicians with how they see themselves in relation to AI technology, but it also involves the patient too, right? It has meaning for how the doctor relates to the patient, and equally how the patient is to feel comfortable with having AI involved in the process. But ultimately, it's this control that we have over both the development of artificial intelligence technologies, but also their application within the medical settings, that really put us in the driving seat, no matter what. So that's just a basic overview of what meaningful human control means in a medical context, and it should help with just navigating the complexities that I've raised throughout this talk. So that brings the talk to an end, and there is a reference list for those who would like to read more deeply on any of the points that I raised. And I think the slides should be made available to anybody who wants them.
That was great, Henry. Thank you so much for that. So we've had a couple questions come in already. So from Clayton Bees, he wants you to talk a little bit about how do we overcome over-promising from previous AI systems and convince clinicians to begin looking at AI recommendations again? And how long does that take to rebuild that trust?
Yeah, that's a great question, because trust really stands at the very center of all of this. And trust doesn't just apply in the medical context. It applies, in fact, right across the entire technological sphere of the modern world. And one of the troubles for artificial intelligence technologies is that because it's so widely used, there are many cases that show the technology going wrong. Of course, there's the Compass algorithm, which has been used for predicting recidivism rates within the prison system, and of course, there's been enormous racial discrimination and bias that's occurred as a result of the design of the Compass algorithm. But there are a whole number of other algorithms that have yielded similar social and cultural problems as a result of the way that they've been designed. And of course, this has undermined the trust that people have in the technology. So it's particularly sort of difficult in a medical context, because AI in a medical context is where perhaps the technology is most powerful and useful. And rather than it being built for, say, social media purposes, within the medical setting, it is designed perhaps with a much sharper objective in mind. So it's a challenging one for the medical space, because we've got these kind of peripheral problems that are happening at the same time, and so it raises trust issues for those tools that are being used by doctors. So as to sort of how we can rebuild the trust, I think this is really a question that does expand beyond just the medical setting, and it's one that really does concern the technology industry on the whole, which is that we need to be building AI technologies that are responsible or responsibly built in basically every setting. Because if that doesn't happen, then the medical context will always be running up against the challenges and concerns that are coming from other fields. So yeah, it's a difficult question to answer, because there are different angles of attack, you might say, just in relation to the issue of trust. But I think the rebuilding has to happen across the board, and if it does that, then the trust will only get stronger. But if trust isn't built into AI sort of from the outset, then it's always going to raise issues and ethical concerns in some way or another. So I know that's a bit of a convoluted answer, but yeah, it's a particularly complex issue, namely that of building trust.
Okay. So that actually segues well into the question that I had that I wanted to ask you is, so because AI learning and insights are based off existing patient records to help anticipate future care needs, is there concern that this could lead to the AI discriminating against certain patient populations that have less access to healthcare and therefore less representation in existing patient records? And if so, what can be done to address that?
Simple answer is that yes. Yes, it can happen, because it has already happened. As I mentioned in my previous response, the COMPASS algorithm is one of the most sort of commonly referenced algorithms that has led to racial discrimination and bias within the system. Particularly the prison system, but the same problems apply, of course, to the medical context when it's using patient records. There are different ways of eliminating and mitigating bias. I mean, some argue that you can never eliminate bias simply because a decision-making process always involves bias, and that is indeed true. Biases are always involved in our thought processes and in any sort of decision, but we can mitigate bias, and there are many ways of doing that. So some of the ways are technical. I know IBM has a suite of tools that are designed for identifying bias within a particular algorithm. And of course, they use AI algorithms for identifying bias in other AI algorithms. So you can sort of see how the technicalities of managing bias are sort of becoming more and more technological, in and of itself. But the technology itself can only do so much I think what is important to understand in relation to bias and discrimination is that they are human biases and discriminations, right? That they are our own biases that we're building into the technology. So there is the task or the project of just understanding our own biases to start with, before we even start building technological solutions for trying to address bias. Because if we don't understand our bias, if we're ignorant of our own biases, then the risk is that we will just translate our biases into any technological system for addressing and eliminating biases in whichever manner, like IBM is doing. So again, this is a very challenging problem, because medical records already involve bias, and there's of course information within medical records, and this applies to data in every sense. There are always biases and information which can lead to biases further down the track, and so a part of the challenge is basically trying to clean data and rid data of the prejudice, you might say, the bias that is already built into previous data sets and previous decision making. So again, it's another complicated challenge, because there's a lot of work involved in trying to cleanse the data and to build technological systems that can, that are basically not biased in the ways that we're familiar with already. So, yeah, again, another convoluted answer. I'm sorry, but I hope that sort of points to just the challenges around bias and discrimination.
Yeah, definitely. And thank you for your answer there. So another question that we have from Blake Houston is, how far can AI go to take over the role of people in hospitals? In what respect to autonomy and independent function?
Is that in relation to the doctors and clinicians themselves?
I believe so. That was the information that I have.
Yeah. Okay. So it's not sort of we're not talking about sort of sort of nurses and other medical staff, because of course the idea of robots coming into the medical setting is of course what many futurists are talking about, and of course it's happening in our own homes, and of course we already have Siri and Alexa and other AI assistants in multiple settings. So so it's interesting if AI does take on a physical form in the form of a robot, that is, and that throws in additional complexity, because of course you begin interacting with AI in a very sort of physical and quasi-human sort of manner, and again that changes the sort of our sensibilities towards working with artificial intelligence in that physical setting. So to address the question, the many forms that AI, well, I should say AI can take many forms. It can just take different forms of what you could just say soft forms, in the form of software, and that of course is just computational systems and algorithms, as I pointed to throughout the talk. But of course it can take different forms in physical form, and of course that adds an additional layer of complexity to the interaction, and it can also change the autonomy and the agency that we we believe that we have and that we feel that we can have. Because once you start talking to a robot as though it's a human, you naturally change your behaviors. You will sort of start making assumptions about the robot, which you wouldn't do in just a software version. So sort of the answer is that yes, autonomy and an agency is increasingly affected the more that AI tools become physical. You could say either more complex and sophisticated in a software manner, and even more so when they're operating in a physical sort of real world manner. So yes, I hope that addresses the sort of the question around autonomy and agency. Happy to elaborate on that if need be.
Okay. So another question from Megan Mitchell now. So you mentioned about learning lessons in responsibility from social media and other industries. How can we also learn from issues within the medical field itself too? For instance, the hesitation that have been necessary to consider, or the hurdles and barriers to overcome related to interoperability or big data?
Yeah, so the lessons that can be learned, I mean, they go in sort of in every direction. And sorry, Jacob, can you just repeat the beginning of that question?
Yeah, so we've talked about learning lessons in responsibility from social media and other industries. So how can we also learn from issues within the medical field itself?
Yeah, so I think this comes back to the notion of meaningful human control, and that doctors and clinicians and really everybody involved in the medical space should see themselves as sort of partaking in the education and development of AI technologies. So it's not simply that AI should be introduced and it's sort of there, in the form of a chair or a table that just has to be used as is. The technology needs to involve the experience, the human experience. It needs to have feedback and and other information which can improve the technology from the inside out. So I think in terms of sort of the lessons learned, those lessons need to be fed back into the technology itself, and not just that, but also the broader sort of social and cultural dynamic of using AI technology in the medical setting, because of it's a dynamic and it's a complex set of relations, and so it can't simply be sort of a one-way street, so to speak, where medical professionals just have to accept the technology as it comes to them. The technology has to be open to the experiences and the lessons that are learned in a way that can then be fed back into the technology itself, so as to make it better in the future. So we're seeing this in relation to other areas of sort of social media and just the fact that there are so many problems emerging in the social sphere, and technology companies they at least say they're trying to remedy those problems, but the same, of course, must also be attempted within the medical space by medical professionals themselves. They need to be feeding back into the development of the technology.
Okay, great. Um, so another question from Clayton Bees. We talked a little bit about it, but what regulatory structure exists to allow an AI to practice at the full license level of a doctor?
Yeah, that's a great question. As far as I'm aware, I don't think there are any AIs that sort of operate as having a full license of a doctor. So I don't think, at least that I'm not aware, but correct me if I'm wrong. But my understanding is that currently the two modes that are in use are the conventional mode and the integrated mode. The fully autonomous mode, again, I think is where it's heading, but I'm at least not aware of it being sort of fully operational, so to speak. But regarding the regulation, this is really where we need regulation sooner rather than later, because a fully autonomous doctor does change the nature of medicine profoundly. And so it's an entirely new kind of medicine, you might say. And in that case, we need a whole new sort of system of regulation and indeed ethics around what that AI patient relationship looks like, as opposed to the traditional doctor-patient relationship. So in terms of just answering the question, I mean, the regulation is being tackled as we speak, and it's definitely not clear as of yet, what the best set of regulations, is for managing fully autonomous sort of doctors, because of course the same applies to fully autonomous cars, right? We haven't yet got to the point of having fully autonomous cars because the system itself is just too immature to implement in the real world. So that's sort of where we currently stand, I think, with sort of fully autonomous doctors. It's sort of analogous to fully autonomous cars.
Okay. So I think we got one last question from Melanie Sage. In talking about addressing the problem with fully autonomous AI systems compared to the integrated system is meaningful human control, which then just brings that back to the AI system not being fully autonomous then. So what can you speak a little bit to the difference then between the autonomous system with meaningful human control versus the integrated system of AI?
Yeah. So, yeah, that's a great question, because as I just mentioned in my previous response, the fully autonomous system does change that doctor-patient relationship profoundly. So, in the more extreme example of that, it might be that there is just no human control involved in that relationship, and so then you have to sort of ask the question, well, how ethical is that relationship? Because of course it again comes back to the issue of trust. How can we trust the fully autonomous version to make recommendations and to interact and engage with the patient in a manner that is firstly medically acceptable, but also just ethically and morally acceptable, because of course sort of essential to the doctor-patient relationship is the sympathy and the compassion and the understanding that the doctor has for the patient. And of course that doctor-patient relationship is very much sort of dependent on the humanness, right? The humanness of that relationship. Whether robots can achieve the same kind of sympathy and empathy as a human can is is an open question. It's of course what designers are trying to sort of do, and of course, you know, we can already see many robots out there that look like human beings and they sort of act similar to human beings, but the question does still remain, and I again pointed to this at the very end of the talk, that, you know, we are the humans, the machines are not. You know, they are non-human entities, despite the artificial intelligence involved. Machines lack everything that humans have, from the compassionate and sort of the emotional capabilities. So yeah, as to the role that meaningful human control plays in that sense, there'd be far less of it, presumably, and so it would again raise ethical questions as to whether a fully autonomous relationship is one that we're happy with, you know, as doctors and as patients. You know, is that one that we can accept? And of course, I think only time will really tell, you know, how much trust we can put into these machines, and also whether or not the machines can relate to us like a human doctor can. So, yeah, as far as things sort of will go in terms of the future, I think the conventional and the integrated modes will definitely be the primary modes for probably, you know, a very good long time.
Okay, great. Well, I believe that's all of the questions that we have. So thank you so much for presenting and helping us celebrate our World Usability Day. We really appreciate your time.
Jacob, thank you very much. I've really enjoyed sort of meeting you all and giving this talk. It's been really interesting for me to look into this myself, and so thank you very much for the opportunity.